Hello everyone, it's August 14th. Alright, let's get to it. Partition list. Given the head of a linked list and a value x, partition it such that all nodes less than x come before nodes let's do this one more time. All nodes less than x comes before nodes greater than or equal to x. You should preserve the original relative order of the nodes in each of the two partitions. So if we say x equal to 3, right? X is the value, so it will be 1, 2, 2 comes here, and 4, 3, 5. You don't have to put 4 on the top. Okay. What do you think? I mean, we can. Yeah, we can now move 2 pointers, right? We can now move 2 pointers. So I have to go from front. If it's smaller, we remain. If it's bigger, if it's bigger, you want to put it back. You know, yeah, I get the value out, right? So if it's this, I remain. If it's this, I will put it to the end. If it's 3, I'll put it to the end. If it's 2, I move this forward. If it's 5, I put it to the end. Yep, I think that will work. But we're gonna do it in Java, so shutter. I think I've never done a linked list in Java before. It will be fun to see how this one goes. And this has to be, yeah, we have to. And I just delete this. Delete this as well. Okay. So this I will say should be defined. Okay, so let's now do public class. All right. No, next. Oh yeah, this is the 2 values, right? And then this is, there's the 3 constructors. Okay, the first constructor just the empty, and this we set the val, and this we set both. Gotcha. Okay, solution. So as I said, we need a front. No, usually we use a dummy, right? Do you need to use a dummy? Yeah, you do need to use a dummy. Okay, so we're gonna do a dummy. How do I do a dummy? List node dummy equals new list node val, doesn't really matter, val is gonna be 0, and next will be head. Okay, so we have a dummy, so we need a list node left. Okay, you also need a right, so left equal to dummy, and list node right equal to dummy, and while right dot next, because I want to put right to the last one. Right equals right dot next. Oh, now equal to no. Okay, so right equals to right now next, and right equals to right dot next, and then pop come out. So this is the right. So we have a left, we have a right. Done. Now what we want to do is go through every single one, right? We need to move it to, because when you move, so it's gonna be the left on next. We check left on next, right? If we put in here And if we're looking at this, then we cannot remove. So what do we say? While left.next is not equal to right, right? Because when it ends, is the left.next equal to, no, that's not right. That's not right. That's not right. So as we go here, like this is the left, okay, and left.next. Yeah, when do we end? It's a good question. When do we end? When do we end? So here doesn't move, so the next is, oh, we also need a node that's moving. Yeah, so left, so we start, left is here, so left is here, and then node is here, right? Node is here, and then node is not smaller than left.next coming here, node move here, bigger, so we move this to the end, and once the node visit the last one, right, and then we say list node tail equals to right. That's the tail node, right? That's the tail node, so that shall be where the node ends. So we have a left, have a right, and then we have a tail, and then list node equal to head. Okay, so while node is not equal to tail, well, node has to go to tail, right? Node has to go to tail. Because we move to the end, so yeah, node, when it reach tail, so I do it one more time. So okay, I'll just say not equal to tail. Okay, so while node is not equal to tail, what do? We check if node.val is smaller than x. In this case, then node equal to node.next, we just move forward, and left equal to left.next, move forward. Perfect. That's fine. Else, right? Else, just node.val is larger or equal to, like in this case, right? In this case, now we need to put this to the end. How do we put this to the end? We say right.next equal to node. Okay, right.next equal to node, and then okay, right.next equal to node. So we put this one, we'll connect to this. Then we need to delete this node from here. How do we delete it? We can say left.next shall equal to node.next, right? Left.next equals to node, so we pop to this. Then what we need to do next is node.next equals to no. Then node equals to left.next. Right, no equals left.next. And left doesn't change. Well, right need to move forward. And a right equals to right.next. Okay, so node will come to this one, and we do it, node will come to this one, and then node just move forward, and then this goes and node come to this one, right? Node equals to left.next, node come to this one, and then node will equal to tail, and it comes out, right? And it comes out, And then we have to do this one more time. Oh, can we? I don't know. I don't know. You know what? Maybe we can go while true. While true. Then we do this. Oh, because the left is always trailing behind, right? So if node goes to next, next will be coming here. Oh, I see. So actually, while left, okay, I do left. While left is not equal to tail, right? So node will be tail, and then node do whatever, node move forward, left move forward, and then while left is not equal, so now left is equal to tail, and then we're done. Then we shall return dummy.next. Okie dokie. Let's see. Two examples. Okay. Number of nodes, I can be empty. So it have to be empty. I'll just do 0, and then we can do 1. 0. These are right. Which one? I think it's empty. Well, what if we handle empty separately? If head is equal to null, return null. How about this? This is one fix. And no. So I think it's this, right? It's this, a single one. Yep. So a single one. Dummy is fine. Left. Right, actually, let's do right equal to head. Okay. While right on next is not equal to, here right on next is equal to. So right will be in the same position. The left and right are in the same position. Tail is the same position. Node is head. While left is not equal to tail. So left is equal to tail. Right? Oh, left is at a dummy. So we actually do it. So node.val. Okay. Node.val is smaller so than x. Then node will move forward, the left will move to tail. That's fine. Right? That's fine. But if it's larger, then we say right.next equals to node. Because node and right is pointing to the same thing. Okay? They're pointing to the same thing. Then right.next equal to node. And left.next equals to node dot next, and the left is at the dummy. Yeah, I think this one is let me write this out. What if I have only one node and we have a dummy, right? So left is here, right is here, okay, and then tail is here as well. So left is not equal to tail, right? And then node is here as well, so node. So if node, if you're at the end, node come to right, then you shouldn't come to right. Right? Node should not come to right. Right is the end of everything. So node shall not come to right. So maybe we can just say node shall not come to right. Because if this case I do, because I say node will put to the end, so right dot next we're pointing, right? We're pointing this way, and you cannot take this out, right? you take this out. Yeah, so how about we say while this and node is not equal to right. Node cannot reach right. Okay, so if we do this, maybe we can handle this one as well. If it's empty, okay, empty. Left is a node, right is empty. Then while right is not equal to null, and so right is empty, tail is empty, node is empty, while left is not equal to tail, and a node. So here node on right. So yeah, I think this one's not necessary once we have the other condition. So we're gonna do that one more time. Okay, so we have this and this. So I probably also do this. I should handle all the situations. Yep, give it a shot. Oh, it was Java. A long time ago. Oh no, I think there's an error. Oh my god. Maybe a infinite loop. Holy crap. I don't like it. Okay, let's think about this one more time. Where did we go wrong? All right, 143052, right? Target is 2, so node is here, and then this putting here, 3 putting here, 0 putting here, 5 putting here. Okay, everything's fine. Everything fine. Now last one is 2. 2 is equal, so I'll put 2 to the back. Oh, I put 2 to the back. Then, yup, that's not the way. That is not the way. You put 2 to the back. So I need to find the first one that gets put, right? That's the one. That's the stopping point. So what I want is the first one. Oh, but we don't know which one is the first one initially. We do. The first one that's larger or equal to. We can do it here. So not the tail, the stop. A terminate condition. Okay. List node term equals no. Okay. So if right val is larger or equal to x and term is equal to no, then we will set term equal to right. Then tail when node and left. Now I'm going to have to the left, and this is going to be node. Node shall not equal to the term, right? Node shall not equal to term. Maybe I don't need this one. Let's try this. Ugh. No, not equal to term. Let's do this. And no, not equal to right. Maybe I have to do this. No. Huh? I didn't make any change. Oh no. No. You have to know the first time when you count to the, oh my god. This node, after it's been put there, that's the Shoot. Okay, so this is not right. This is not right. But we still have the term, right? And we'll do this. So and this is the first time, right? Right on X we do right equals to right on X. So this right is the end. We're gonna say if, right? If term is equal to no, then we set term equal to right. This is where the termination should be, because the first one gets put at the back. Okay, so while we handle all this, then we say if node is equal to terminal, then all shall break. So extra break condition. Okay, let's put this one there. This one right. Okay, so can we not do this now? Because I have the term. Oh, what if everybody is smaller? If everybody is smaller, then term is going to be null. Then I think, yeah, I think it should be fine. I can do while true. Right? I can do while true. While node is not equal to term. Then I don't need this. Nope. Gosh. Alright, so maybe this one not equal to term and the node not equal to right. I do both. So right is the end. So if the node get to the end, yeah, that's it. Term is the terminal condition, right? So this is the first node gets placed after the current tail. So if that's the case, we don't need tail, right? Tail is not necessary. We have dummy, left, right, term, get it right, node, right, yep. One more time. Okay, try this. Now this one's right. It took some effort to get everything in place. I wonder what method I used in the past. Curious. That's 2019. 86. Use 2 pointers, right? One at the front, one on left, and the other on right. Whenever a node whose value is larger or equal to x is encountered, move that node to right.next. Otherwise, progress left forward. Now the terminal condition is a bit tricky. We use a separate term node to mark the first node that gets placed after the original tail. So once the traversal hits that node, we know all the nodes have been handled. Okay, so that was 1 year ago. Dummy small, dummy big. Oh, you gotta be kidding me. Bigger. Current val. Yeah, I think I just have 2. So you don't have to put to the end. You just all the smaller ones you placed, all the bigger ones you placed to the bigger. All the smaller ones you just keep moving forward. So once we hit to the end, you do this. Ah, that's smarter. That is smarter. Oh, this is the same. Oh, wait on. Uh-huh. Yeah, similar idea. But I like this one better. I like the Python method better. Just set up 2. Yeah, it's gonna be much simpler than this. Hold on. Let's copy this up first and write another solution for this. Okay, then let's write the other one. Use 2 dummy heads. Right, so dummy small, yeah. And it's gonna be dummy big. Just list node, doesn't really matter. And then we need node equal to head. That's about it, right? Oh my, this is so much easier. While node is not equal to null, if node.val is smaller than null equal to node.next. Perfect. Else we'll say, we'll get it out. Then we'll say dummy big, right? Dot next equal to node. And yeah, we need 2. We need a dummy small and list node pre equal to dummy small and dummy big. Node is this. All right, so dummy big will equal to this, and then pre dot next equals this, and null dot next equals to null. Null equals dummy, no, pre dot next, and then this is dummy big. Don't you need something on the dummy big? Like pre small and pre big, because you have to keep growing, right? Yeah. So pre small, then list. Oh, yeah, pre small and list node pre big. I don't remember I use a. I should be pre big. This is pre small, right? Node.next equals a no, and then this is pre small, and then pre big. Okay. Once we done, then pre small. Oh, wait, pre small, and then move forward as well. Pre small dot next equals pre small equals pre small dot next, and then at the end pre small dot next equal to dummy big dot next. Then we return dummy small dot next, right? This works. Yeah, I think this one works for everybody. Much easier to reason with. Yeah, it's much easier to reason with. But I remember this one only has. Do I have a dummy small and dummy big? Bigger. I have a bigger. Yeah, bigger. Yeah, it's fine. It's the same thing. Yep. I like this one better. This one is definitely a better solution. Okay, done. Now let's go back to the struggle from yesterday. We just have an error. Don't worry. Let's take a look. What are we getting wrong? Output 7 is supposed to be 6. So we did one more. 5, 2, 9, minus 6, 2, minus 5, minus 1, 0, minus 5. All right. Let's see how many can we get. Biggest is 9, so this is 1. Okay. Next one is 5. If it's 5, I can get 2. Next is 2. Are you telling me which one goes first will matter? Well, I mean, 2. If you go this 2, it'll give you 1, right? And then go this 2, will give you 3, because you go 2, 5, 9. And we'll go this. If you go this first, so we go this first, that's what we get. And then 0. So this shall be 4. And then minus 1 shall be 5. Minus 5. If I go this first, it'll be 2. But this will always get 6. And this, because it's equal, so I'll show off will be 6. And then minus 6. Ew. What is this thing? If this thing will become 6 and this one becomes 7. Let's see what's the issue here. Because this is 6. Now I have another minus 5, right? And this minus 5. Because this is 6. So this minus 5 shall be 6 as well. But hold on. Is it? This is 6. Because this can do this. For this one, the row, this will give you 2. This row, the 6 is something that's equal, but you cannot go. This is actually should be 1. I think we have something error here. This should be 1. No, this should be 2. Right? This should be 2. Hold on. Basically, oh. So once it's equal, we need to know the second biggest. Oh, you gotta be kidding me. Really? But yeah, like if you are equal to the current value, it's equal to something previous, right? They're equal. And they cannot go there. So they have to find what's the other, the second largest value, right? We need to find the second largest value. We don't even need to know what it is. We just need to find the second largest value. The second largest value. So we need to keep count of 2 things, right? The largest value and who the largest value is at the moment, and the second largest value. We don't need to care what the second largest value. We need the second value, but we don't. Yeah, we need. Do one more time. We need to know the value that gives you the maximum cell counts, and we need the second largest cell count. Okay, and then each time, if it's a unique value, then we just upgrade both. If it's the same, then we need to check the second largest. So if that's the case, let's redo this. Number of cells. No, we don't need to do this. Okay, here's the thing. So what we want is max cell count, right? Second max cell count, and the max the cell value at max cell count. So 3 values. Okay, 3 values. So we're trying to do 3 values. Okay, blah blah blah. If the current, the row cell, right, if it's equal to the current value, then what we need to do is just to check the cell at second maximum count, and we do that plus 1, right? So what we're trying to do is find R. Okay, so if it's equal to this, then we don't need to do any of this. We just say R shall equal to row max cell I, the second max cell count. So 0, 1, 2 plus 1. Okay. We don't have to do anything. We don't have to do anything. Right? The row, and then because I cannot go with a max cell count, we have to do the second max cell count, because the max cell count must be, because we go from large to small, so the max cell count must be something in the same value as me, but I cannot take it, so I have to take the second. And else if it's not the same, but R equal to this, but we have to update, right? The second, for this row we have a max cell count and a second max cell count. Now I go plus 1, right? Then it is not possible that will be larger than this, but if I get bigger than the second, but you know what? No, this has to be at the end, at the very end. Okay, at the very end. So else will be this. So I think I do this and I do this one as well. So we simply say column, so equal to column max cell j 2 plus 1 if it's equal. Otherwise, it will be this. Okay. So once you have all these, then you can say the current max cell will be this. Then you go back, right? Then you go, I can update this one as well. Then you have to update, right? Then you update. How do you update? You check, right? You check because you have a max count and a second max count. So you check the row for the max count. If it's more than the max count, you update this, put this one here. If it's not, then you check for the second max count and you update here. If not, yes. So we get a max cell count. Then we update, right? We update row max cells and column max cells, right? Then we say if current max cells is larger than row max cell I 0. If that's the case, row max cell I 0 shall equal to current max cells and row max cells I 2 shall equal to row max cells I 0. We swap, right? And this equal to this, and this will equal to this. And row max cells I 1 will equal to V. Okay. If current max cells is larger than row max cells I 2, right? Then row max cells I 2 shall equal to current max cells. This is the second largest. Then we repeat this whole thing, okay, for the column. So current max cells, so we say column, right? This is gonna be column, and order this become J. All right, let's give this a shot. See if it makes sense. Does it make sense? So far, so good. All right, give it a shot. Ugh. Nope. Oh, we just fall back to trial and error. Now, what's the problem now? We have a single column. We have -2, 8, -4, -2, -1, 7, -2. Okay, so right, 1, 2, 3. Wait, 1, 2, 3. Come on. 1, 2, 3, 4, 5, 6. Okay. So the largest is this will be 1. Then this will be 2. All right, because it can come here. Next, what? 8, 7, -1. Okay, so this will be 3. So 1, 2, 3. -2. Oh god, I have 3 -2. Doesn't matter, I just pick one. Which one do you think will come first? Well, I'm sorting, so based on I, yeah, I, so, and then in reverse, right? So the biggest I counts, so this one counts first. So this will be 4, right? Then this. Okay, so when we do this, previous is equal, so it will be second largest. So that second largest should be 3. So this one will be 4, right? So it will be 4 in the column. But in the row, in the row, I shall set not to be 0, right? Set it not to be 0. Yeah, I shouldn't set it to 0. But anyway, in a row, it will not be equal to the current value, and just be 1, right? Row will just be 1. So this one shall be 4. So in my case, this one shall be 4, right? And then in the same case, this one shall be 4 as well. Then we go to minus 4, shall be 5. I got 6. That is bonkers. That is absolutely bonkers. I hated it. That's why I am going to test it. Absolutely bonkers. Expected 5. All right, I'm going to comment on this. For one thing, okay, these shall be math.inf. Okay, math.inf. All right. What are we doing here? We shall do print current max cells. Okay. You know what? RC row max cells I and column max cells J. Of course, we have to also print out, oh my god, Vij. So many. All right, Vij. The rows are correct. So the rows are always 1. Understandable. The column, 1, 2, 3, 4, 5. Yeah, how has this one become 6? The column is 5. 5. I got a 5. That ain't right. How we get a 5? This I got a 5. That's not right. It's minus 2, right? I got minus 2. Minus 2, I take a look. Previous is minus 2. I mean, row is fine, it's column, right? Column is minus 2. Right? And then I say column J, 2 is 3 plus 1 shall be 4. It shall be 4. What? I don't understand. I do not understand. What the hell? J, column max, row max. Everything looks right. Yeah, look, it looks right. It's oh, actually it doesn't look right. This one's wrong as well already. It's 4. And hold on. Where did we get wrong? All right, first start. You know what? We shall do it this way. Don't print here, so we know the updated value. 180, 180. That's fine. Oh, I think it's the row has an issue. Row. Second. The row become 2. That's not right. How is that possible? Yeah, 7 is 5. So when the 5 comes out, it should be 0. Why did it become 2? Wait, it doesn't make any sense. It doesn't make any sense. If current is larger than... Oh, hold on. It doesn't make sense. It does make sense. The row... Yeah, okay. Sorry, it doesn't make sense. A row is fine. We don't have to worry about row anyway. So -1, we got 3. That's fine. -2, we got 4. That's fine. Oh, I see. The next one. This gets to... Oh. Yep, this should be 4. Then will become... Well, it should be... Still should be 3. What are you saying? What are you saying? It's a 4. Right? Because it's equal to something, okay, then the maximum should be the same. Okay? And then, oh, because it's the same, so it should not come to... So maybe we should say current max is larger or equal to, right? Because it has to, so if we do larger or equal to, no. Still not right. How come it's still not right? If I do larger or equal to, right? Because this is 4. And 4 shall be... Now this one's fine. It's this one, right? 4 is larger or equal to max row. Then... Oh, I swap. Damn. Okay, so basically, if it's equal to, we shall... if it's equal to the current max, then we don't move anything. Alright? Does that make sense? If it's equal to... Yeah, so, okay, this is fine. If this is equal to, we shall pass. And current, this is not equal to row max I and a 0. Yeah, this update logic is slightly convoluted. Column J. What? Oh, this. There we go. It's like, my God. Keep giving me error. All right. I just try and error this thing. Yeah. We are just try and error this thing. God. I'm gonna have to change the... Yeah, I'm gonna change the variable name. It just looks too bad. Alright, let me change the variable names. Rows, columns, okay? So I will do all this, rows. Do all this, columns, okay? And we can say this if rows I 1 equal to v, else rows I 0. Okay, so one line to handle this, and we'll copy and paste. So we can one line to handle this. Columns J. Okay, one line. Then we say, don't say this. Don't say this, we say current. Update. Current, blah, blah, blah. Else this, we do this. If current, yeah. So we make it look nicer. All right. Let's see. Is this one right? Oh, that was tough. That was tough. How many have we passed? Oh, 30 more test cases. Jeez. Oh, absolutely. Yeah, it's a tough one. It's a tough one, not because like it's really hard. I think it's just the edge cases. There's so many edge cases to consider. What is this one? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6 by 5. Ugh. Yeah, let's do a new one. 6 by 5. That's a huge 6 rows, 5 columns. So 1, 2, 3, 4, 5. 1, 2, 3, 4. My, -1. Oh, this one is hard even to write it out. 8 minus 1. You know what? Let me see if we simplify this. Can we simplify this? By simplify, let's say, how about we just do 2? Does it work? Okay. How about we do the we do 3? Just see. One of them shall be wrong. Ugh. Okay. How about we remove the 2 in the middle? Okay. Does this one work? Oh, you gotta be kidding me. It's like it has to be all of them. How about we just randomly just delete one of them? Perfect. Can we delete another one? Yes. Nice. Okay, I think I can handle this. All right, let me just let's just do a new one. So now it's gonna be 4 rows and 5 columns. Yeah, that's much easier. 1, 2, 3. 1, 2, 3, 4. Okay. -1, -9, 7, 2, 2. 9, 5, 0, -2, 2. 6, 6, 6. -9, 2. -3, -6. 9, 6, 2. Okay. So this is the DP table. 1, 2, 3. 1, 2, 3, 4. Okay. Answer is what? Answer is 7. I got 8. Okay. The largest is 9. So this 9 I get, and then we go low to top. So this one 1. Okay, this one 1. Next 6. So we 2. Large first. So this one goes first. So this will be 2. This is the same, so this shall be also, oh, here, right? No, it should be fine because that should be the +1, right? So this should be 1. shall be 1. Right, and then this shall be 2. Right, this shall be 2. Then what? 6, 9, that's, oh, 7. Oh, God. Didn't see 7 here. So 7. So that should be 2. 7 is easy. Now 6. Okay, this is still 2. And this will be 3. Right? It's going to be 6, 7, 9. It's going to be 3. This shall still be 1. And this, that's a 2. Oh, but this 1. Oh. I kind of see the problem. The maximum and the second maximum belong to the same thing. Oh, yep. So here is fine, but I think this string of 2 is giving me issue. You cannot, like right here, you cannot say if it's equal, then you immediately go for the second largest. We know the largest is the same, but the second largest can be the same as well. Then what do? We have to find the third largest. There is no end to this. There's no end. So what should this be? Like, if I have a bunch of equals, you need to find the first one that's not equal on this row. Oh God, first one that's not equal on this row. And you record its value, but you record it. Do you need to record its value? That's the thing. Do you need to record its value? But you should, right? Because from this, what's the maximum? You need to record its value. But once you record its value, if it's so the value is not the second largest, but the largest value that's not equal to the current one. That's the condition, right? Which means it's still correct, but when you update, when you update you should not update, right? Is that what you're trying to say? If the current is larger than the biggest, then yes, we shall update it. Okay, so here's what I think. I think this is still right, but this is not the second max cell. It's the max cell count, right? From a different cell value. That's what this is. So these two still valid. This is still valid, but this needs to be careful. So if current is larger than this, right? If rows I1 is not equal to V, then we do this. It's fine. Okay? If it's equal to V, because if it's not equal to V, then we basically, yeah, we shift this current to this. Yeah, that's all fine. If it's equal to V, right, then we just do rows I0 equal to V. That's it. Else, if current is larger than this, okay, if current is larger than rows I2, so the current is smaller. Current is smaller than the the biggest, but it's bigger than that. It has nothing to do with who's bigger, actually. It doesn't really matter who's big. If the current is equal to the V, the V is equal to this, then you should never update it, right? You should never update it. You should only update if it's different from. So what I think is this one can just be ignored. And here I say if columns J1 is not equal to V, then we do this. Else columns J1, J0 equal to current. No, that's now V is current, which means it's larger than, but it's the same. So I just do this, and this is not necessary. Is this one right? Okay. Okay. Try this one more time. I'll put this one here as well. All right. It should be 7. Oh yeah, of course. I haven't updated this one. Hold on. All right. Last shot for today. Boom! I got this. Holy crap. Holy crap. Oof. That was pretty good runtime, honestly. Alright, we're gonna do this one more time. Okay? We'll do this one more time tomorrow in Java, and so we can think back as another time. Not tough in terms of implementation or intuition, but quite difficult. To figure out all the edge cases without trial and error. The general idea is DP, right? Is DP where is DP for each row and column, where DPI or DPJ, right, records the max cell count, the value at the max cell count, and the max cell count at a cell value different from the max cell count value for rows or columns, right? Then we traverse the matrix from largest value to smallest, and for each val we check its rows I and columns J, right? Yeah, we should say rows I or columns J. All right, we check this. If the val is different from the val that results in the max count, we can simply increment it. Different from now we increment then the current, right? Then the current max val is the previous max val, max cell count is the previous max cell count plus 1. Otherwise, the current max cell count is the previous max cell count other than the max cell count value, max cell other than plus 1. After obtaining the current max cell count, right, go through rows and columns. We need to update rows and columns. Update only happens if the current max cell count is bigger than before. But pay attention, right? Pay attention that when the current val is the same as the previous val that leads to max cell count, we do not update this thing. Oh, I meant it took a while. Okie dokie. That was good. That was actually very good. DP. Don't know what happened. I might publish this, but if we don't publish this, you probably need to rewrite this. Oh shoot. Yep, my bad. Log mn. Yeah. We'll have to rewrite this if you want to publish. Let's publish the Java version. Yeah, let's do that. Yeah, let's do this tomorrow and publish my first Java thing here. Oh, that'll be fun. That'll be fun. Okay, but that's it. That's it for today. I will see you guys tomorrow. Adios.